to to carry out the comments from command window, or either I can start a new script. Okay, and then in the new scripts I can say I can see the name, the title of the file. Then if I say x equals 5, okay, and then I run this section, then I see in the command window I have the output. Okay, I have the output. Now this is one way. The other way is, which is the subject of today, is the live script. The live script, if I click on this icon, it will start a new iScript, live script. And then in this iScript, if live script, if I write my variables, x equals 3, okay, and then I run this section, I can see at the right-hand side, okay, the output for the comments I wrote. If I write y equals 5, and then z equals y plus x. Okay. Now, for example, if I want to suppress the output at the right-hand side, I can write the semicolon and then run the comment. Then here in the live script, I can see the output. Here we have different options. For example, output on the right. The other option is output in line. Then I can see it here down the comments in line, and then output hide the code. I can see only the output. And now for the live editor, there are some very good things when we look at, for example, we want to use it in teaching, which is the way we can save, the way we can handle this. There are some interesting things. For example, here I can save it as a PDF. I can save it as Word. I can export it to HTML, and then I can export to LaTeX. Now for this, I prepared already, just to minimize the time. Okay, here I prepared something, for example, an exercise or example. For example, here I can write whatever I want to write. For example, if I cut this, okay, I can write here. Okay, and then I can handle this. For example, once I write the title, okay, I can click here and then I choose to make it, for example, normal. I can make it title, okay, and then here the body, I can make it normal. Now, like in Word, software, we can save those as headings. Now, for example, here I wrote the introduction, and then I gave heading 1. You can give heading 2, heading 3, okay, and then once we export it, for example, to Word, then we will see the same headings as you want them in the Word. Then this is also, you will have a nice document where you can make further manipulation on that. The other thing is I can here add a link, insert hyperlink. Okay, for example, this. If I click on it, it will take me to the source. Then I need only to highlight the word, okay, and then put the link, write my link here, and then press OK. I can insert images from image. I can import the image. Okay, any image, for example, I can import this and add it here. If I want to delete, I can select and then I can delete. Now this is I make heading 1. Also, there are some nice comments, shortcuts here Then for heading 1, I can press Control Shift 1, Control Shift 2, Control Shift 3, and then for the title, I can press Control Alt L. So sometimes also I need to write equations. Okay, then also from here, insert equation, I can insert the equation, write it the same way as I do in Word file. Also here, for example, you can highlight. We have those things bold like in Word writing. And also there are some advanced things. For example, when I look at control, there are here some options. For example, I can assign variable, okay, and then I can control it from here. When I deliver the my presentation, then it would be easier for me to show the difference if I have to change a variable in which, for example, the output would change as well. Here there are some tasks I can add them from the apps as well. Those are advanced ones. Now, when it comes, for example, here, if I want to write the heading, that is heading 1. Then if I want to write my code, then I press code, okay, and then it will be, as you see, it will be in gray. If I want to break a section, insert a new command or new command line, I can insert new command line. If I want to delete, I can just press backspace, or I can press delete. So this is how we can use this the live script. Later on, once we start our first example, I will show we will be looking at how we can import this as Word file once we have complete document, and then maybe if you need some manipulations for writing a document or writing questions, that could be possible as well. Now, one thing is also there are some advanced features for example, in Matlab, where we can use write reports. Okay, then here there are apps. There is an app in Matlab. We can write the report, and then it will give the same, except for example, there will be the cover page, okay, and content as well. But here also we can add the content once we finish. For example, the our document. Now, before starting, you will have, for example, to save. If you run this, it will run. It will not ask you to save it. Okay, I think the normal script would ask you to save it before running. This would not ask to save. If you want to save it, you can give it any name and then save it. Now I'll close this and start one of the examples in Symbolic Matlab. Then in this exercise, we have the modeling of a bungee jump. Then, as you know, this is common example between engineering and math as well, since the output would be a differential equation. Then in here, I wrote the details of the problem, which is a jumper is jumping from the bridge. Okay, and then this would be simulated as mass spring system. Then if we apply the Newton's law on the motion, on the free body diagram on the mass, then the equation of motion would be this. Or also I can use LaTeX to write the equation. Okay, from here. Insert equation from LaTeX equation. You can import it if you want, or you can, will be helpful, for example, for further manipulation. Some details I put here, the link, for example, if somebody is interested about this problem itself, or when we send it to students, maybe they will click on those and then read further about this. Now, the first comment, to start with writing the symbolic equation, I would write here on my first. Okay, I will be defining the variables. If I want, I can write clear. Okay, if I want to run this, okay, I'm just clearing. Okay, I'm just clearing this. Now, I will have to define my variables. Now, symbolic. Okay, symbolic y of t. Okay, which is the vertical motion of the jumper. And then I will define, as we see here from the equation of motion, I have the m, which is the mass of the jumper, and then the second derivative of y plus b, first derivative of y, the velocity, plus k times y of t. Then those are the factors. The k is the factor rate for the spring, which is the factor rate for the rope. Okay, and then B is the resistance from the air, which is acting as a damp. Now I will define B, K, and then M. Then let me first of all suppress this. When I run this, okay, so as we run the first line of the comments, we can see here the variables are now defined. I have B and K and M, and then T and Y. Now, if we look at those the factors B and K and M, those are defined as symbol SYM. Okay, if I click on them, so I can see this is assigned as symbolic variable. Now, since I defined also here a function, which is y of t, now I can see this is a symbolic function as well. So those are defined as symbolic now, and then now I can write the equation of motion. I will write m times the differentiation, okay, and then I will have the y of t. Okay, and then this is to the second order. Okay, then this will define the second order for the differentiation of y plus b times okay, and then in the same way I will have to define, okay, the first derivative with respect to t, okay, plus k times y of t. Okay, and all of this I will assign double equal, will be assigned the value of 0. If I run the code, then I can see I got here a very nice, neat equation. If I stand on this, which is a symbolic, now sometimes I might need to make assumptions when I'm solving problem. Then this is in assume. This is also a function in symbolic math. Okay, then I'm going to assume y of t is real. Okay, there are different when for example you want more information about this, just have to okay, write it here in the help. Okay, and then click OK here, and then it will go to show you with more details about this function. There are many things, for example, you can assume when using this assumption. There is also the assume also. Okay, now sometimes as we solve the problem, sometimes you might need to make more assumptions, okay, through the solution. Then you add assume also. I would assume also b, k, and m as vector. Okay, I can define them, and then give them the values as vector as well. I will assume them as positive. Then if I run this, okay, then the assumptions are there. Now, for example, I need to give values for M and B and K to solve my problem. I can't later on, this is not necessarily here, but you can make it later on. For example, if I write the equation of motion will be equal, I will substitute, okay, the values for B and K and M, where now here it says the first thing I'm having the equation I already defined up there, okay, and then I will assign the variables b, k, and m, and then as an array I will assign the values for b 4, 15 for k, and 75 for the mass. If I run this, then the values were substituted in the original equation. Now I have this differential equation, second order. I need to solve it. Then, as you know, to solve this equation, I need to the initial conditions. Setting the initial conditions, I have the I can define the initial condition 1, which will be equal the y, okay, the position of the jumper at time 0, okay, and then I'm giving this at 80 meters, okay, because once, for example, the jumper will jump, and then the before it will be free fall, okay, and then once he jump and then it reach the maximum length for the rope, then the height would be 80. Now this is I took only one case. I didn't take the free fall because of time constraint, but this is doable as well. We can solve. Now this is the first condition. Initial condition, first initial condition. Then the second initial condition, I can define the derivative of y. Okay, then that is because this the velocity. I will have to define the function for it. Then this is the differentiation of first differentiation of the derivative of y. Okay, and then the second IC2, second condition would be the dy, okay, at time 0, which is the velocity at time 0 once it reaches the maximum length of the rope, which is equal, I will give any number, 60 meters per second, for example, and then I will run this. Now I have the first condition and then second condition. I can solve the differential equation. Then I will write solve the differential equation. Then I can use dsolve. Okay, then dsolve. Then there are two functions. First one is solve, can solve an equation. Dsolve can solve the differential equation. Now I have to define the equation of motion, okay, with respect taking into account the IC1 and then IC2. Now here the solution, I can see the solution for the differential equation. If you want, you can, for example, those you don't need them anymore to appear on the right side hand side, then we can suppress them. And now I write the solution for that. Then I can plot. Okay, I can plot the attenuation of the motion. Then I will take the f plot. Okay, it will plot the function. Then I will plot the y solve. Okay, and then within a range, for example, I will take from one within a range of time from 0 to 160 seconds. Then here, if I click on this, okay, if I click on this, the plot appears here. I can do other further modifications. For example, I can add the once I click on it, the figure here will be active. Then if I click on X label, then I can write the label time. I can label it. Okay, Y label. Response, or I can say Y of t. I can write the title for this. Animation. Oh. Then further, for example, I can add different things. I can add the grid. Okay, so as we see here, the code appears, and then I can upgrade the code. Then I can update the code, and then the code will be part of my solution. Then for later on, for example, if I want to do some modifications, I can change those values, and then it will be refining. One of the things also I can add, if I want to, I can use this also in, sometimes making questions is difficult. I can add an arrow. Okay, and then I'd ask the student what is the, for example, the frequency of this wave. Okay? Then it keeps updating. If I want to go and then this might be, if I change again, I give, I can take this actually, I can save it later on. Okay, for example, I save this as Word file. If I want to make more questions, I can change the values, for example, give different values. Then for the same question, you might have different versions to make for the questions. If you are preparing question bank. Then here we have different things. You can explore them. Also, we can make subplot, different views. Now one more thing. This is here I can I included for example, to calculate the length of this curve using this equation. Then this is only to show the integration integration function when using in symbolic math. Then I can say the traveled distance. I will define this function, which is the integration. Okay, I'm just applying this formula of the square root, okay, which has the value of 1 plus the differentiation of y solution, which is the function I'm trying, which is the equation I'm trying to integrate, okay, with respect to time. Okay, and then this is would be to the power 2, and then from 0 to, for example, I can put 120 seconds. Okay. So here I can see the distance. Okay, apparently here.
The power, doctor, the power is 2 for different derivative only.
Yeah, here power, right? I wrote the power.
But the power should be for the derivative only, not for all power.
Yeah, then the power, yeah, and the power also only for the derivative here. Then I missed to.
No, it's not for
Hold
derivative
on.
only.
Then the integration of the square root 1 plus the differentiation of the y solved with respect to t, right? Then I have power of 2, right? Then here I have I think I have bracket, right? I have the integration of the square root 1 plus the.
You need to add the bracket after the plus bracket derivative, then square.
Hold
After
on.
plus, after plus.
Where there's no yeah, here, right? Yeah, 1 plus.
Yes, there.
Yes, yeah, 1 plus. Yeah, here. Okay, yeah. Then here is the. No, I should have made this maybe bigger. Or see it clearly. Yeah. Yeah, here then. I have the answer now. As you see, the answer is also in symbolic, which is good as well. If I want to make it, if I want to keep it this way. Otherwise, for example, I can copy this, the distance travel. Okay, and then I can make this. I can write the double. Okay, then it will give me the value for. Okay, then the answer here, for example, it gives me the value in numeric, right? Then the answer here, as you see, the value is numeric. If I want to use this this variable, for example, in filter solutions. Now, for example, I finished my presentation for this example. I can save it as a PDF. Okay, so here I have a very neat document. Later on, for example, if you want to make some changes, you may save it as Word file. So in this Word file, you can change, for example, if you want to remove something to make questions or to make it to add some information or to delete some information, you can manipulate it here. Okay, now the equations are exported as photos, but for example, if you want, you can right click on the question you want to take, and then you can take it. If you press copy, it will take it as photo, and then you have the LaTeX, and then copy as MathML. Here, for example, if you want to do some modifications, change numbers, you can do this as well. Now, how we can do this, for example, in Respondus, I have prepared one question. For example, let me open the document first. Here. Here I will have the, I prepared, for example, this question. I put question one, for example, I put whatever I want. I put the graph, okay, and then I formulated this, find the natural frequency from the graph. Then I put the options for that question. Then from Respondus, I can import questions, and then Microsoft Word, browse. Okay, okay, I can append, for example, with the current file, and then preview. No warnings. And then click OK. When I come to preview, I can see the question here. And also there are different means to import questions from Matlab. As I said, there is a PDF or HTML. If I export this as HTML, then click OK. Now here the link in Respondus, when I create question, I have this HTML editor. I can bring, if I press Ctrl U, okay, then I can take this code Ctrl A, and then export it here, paste it, and then click OK. If I click on preview, then actually I will not see that much because this, I don't know, the respondents I checked with them is limited for the HTML. It doesn't take too much. But one way to solve this problem is if the document is saved as PDF, then the PDF can be saved as photos. Okay, and then the photos will be imported. For example, if I take the one I saved here, and then I save it as GBG. Okay, then those here files for example, I will take this and then increase, for example, the view. Sometimes I might need to change the preview so I can have clear printout for the question. So this is how in Respondus it can be implemented for building questions. Also for this document, there is from Respondus this file. Okay, this file from Respondus sample file, it already exists. I can share it with you from the internet. You can download it. It is sample file where, for example, you can use it to build questions. You can write questions, write for different options. Okay, actually, this is there are different type of questions. You can use it as template to build your questions. But the only thing here, for example, when you look at the equation, you might need to save this file as Word 97. Okay, if you save it like this, then it will save the equations as photos. So this is how we can use the Matlab to deliver, to use it in class or for building questions. Now, the other example I want to share with you, which shows the capabilities of the math, symbolic math, which is I'll close this. Later on, I will be sharing with you those files. Here I will have the now in this example, it shows how we can solve different equations if we have multiple equations and then we want to solve them. Solve equation of multiple variables. Here I'm defining the my symbols A and B, and then the first equation is multiplication of A and B equals 18, and then the second equation is the the sum of those two variables. Now to solve those two, of course, those the equations can be more complicated, but I chose them to be simple, just to show the comment. Then if I define the solution, A solution, and then B solution, then the the function is solve, then now I need to write the equations. The first equation is this equation, and then the second equation is the addition, and then solve for A and B. Then here it gives me all the options. For example, for A and B, then first case 6 and 3, and then the B would be in the second case 3 and 6. I can use assumptions here, for example, to narrow down. If I assume A is less than B, then here I will get only one answer, which is A equal 3 and B equal 6. There is also the multiplications, manipulations, and simplifications of symbolic equations. Here, for example, I wrote already the code, which is y is given by this equation. Then, if I run this, y would be written here at the right-hand side. But then I can expand this expression, expand y. Then I will get expanded, and then the other, I can simplify. Sometimes I need to simplify the answer, then simplify y. Okay, then I got this simplified as the factor. Also, there is the y factor. I can take a factor for this of y. Okay, and then I will call it y factor. Then here the Matlab show them as an array. The first factor is x. The second factor is x power 2 minus 8. Further on, if I need to extract the first element in the array, I can do this, and then the second element also I can do it. One more example I want to show you, which is very helpful, I think, when we're writing equations. Now, in this example from Matlab, which shows the robot arm visualization of an arm, okay, which with two variables, theta 1 and theta 2. If I define the equation as given here, L1 times cosine theta 1 plus L2 cosine theta 1 plus theta 2, then I can write them there. Okay, y, Lx and y. Okay, if I run them, I can see them here written very neatly. However, if you write them in the comment, okay, we still see them as, okay, as an expression. Here we can see them as equation. You can take it, right click, and then we can import it. I can, for example, calculate f. I can define a function f of x, which is a function of two variables, theta1 and theta2, in which I will substitute in x some values for x, L1, L2. We'll give the values 4 and 2. And then if I do the same for y, change this. And then here I have the function defined, then break a new section. Then, for example, I can calculate the x position for a given value of theta pi over 8, okay, and then theta 2 pi divided by 6. Then we'll define the same y position will be fy of. Here I have the values. Then the interesting thing is I still have the values as symbolic. One thing, if, for example, if I click on this command line, then at the right hand side it will show me the answer, and then if I click on the answer, it will show me the code for this output. One more thing, for example, if I want to find the put another question, another thing, I want to calculate the the theta or the angles for a given position, then I can define solve the function. I can solve those two functions. Solve for x equals, for example, 3, and then y equals 5. Okay, and then the variables are theta 1 and theta 2. Okay. Then this function here I can write
Hello.
Solution.
Hello. Hello. Assalamu alaikum. Don't. Oh.
Here I made a mistake, fy. And then here I have the answer for theta 1 and theta 2. Of course, I can have the numeric value for theta 1 and Then here I got the answer, which is in radians. So this is the introduction to math, symbolic math. I will put here in the, I think in the chat box. Maybe later on I will share, I will send this as well. So this is my presentation. I hope it was helpful for you. If you have any question, as I said, I'm also I'm beginner to symbolic math, and then I would welcome if you have any question. Then we can learn together. I will stop sharing now. This is the this is the link for the file I put, and then also I will I have a survey, little survey. It will take 1 minute to give me your feedback about the about your interest. Any question? Thank you for attending. It would take more than this actually. This PD already exists in Matlab. Then you can, it's 2 to 3 hours. You can follow this. It's interesting. But what I liked about it is the way, for example, we can use the live editor with the symbolic math, and then for preparing material for educational, for academic purpose, and then for writing questions as well. Thank you very much.